Good morning. This is Mr. Springer, and got a little bit of a note packet for you to fill out. And this video will help you do that. And so you can feel free to pause and go back at any time you don't want to, because it's a video for you to watch. We're looking at properties of matter today. And we should probably start with what is matter. Matter is anything that has mass and volume. You could say it takes up space. But taking up space is volume. Almost anything you can see or touch is matter. And the only things that are not matter are forms of energy, such as light and sound. And just as a spoiler alert here, mass and volume are used to calculate density. And so anything that's matter has density that can be calculated. Even air, which is a form of matter, we could calculate its density. And we'll see that a little bit later, perhaps. Mass is the amount of matter in an object. Mass is measured on a balance. Ancient balances looked like this. You may have seen those on old movies or TV shows. And probably you'll never use one of those unless you just intentionally go out and get one. But you put an object of known mass on one side and then the object you're weighing on the other, and when they are level, then it's balanced, and you know what the mass is. Our balances look more like this. It's an electronic balance, not a scale. And the SI unit for mass is a kilogram. But for smaller objects, we can use grams. And that works very nicely for us. All right, next page. While mass is the measurement of the amount of matter in an object, weight is a measure of the force of gravity pulling down on an object due to its mass. So weight and mass obviously are not the same. The SI unit for mass is the Newton. And the English unit for weight is the pound, and the pound is abbreviated LB, and I'm not exactly sure how they get LB from pound, but that's the way it is. Force of gravity on Earth is 9.8 meters per second squared. That's the attraction that the Earth has for objects. So the weight of an object with a mass of 1 kilogram would be 1 kilogram times 9.8 meters per second squared, which would be 9.8 kilograms meters per second squared, or 9.8 newtons. That is the Newton. A 1 kilogram mass has a weight of 2.2 pounds if you want to use the pound scale for that. So, because so far none of us have been into space, we can think of mass and weight as being proportional. The more mass an object has, the more it weighs. We could even say to weigh things in grams or we can weigh things in grams or kilograms here in 8th grade science class, but physics, you may not be able to get away with that. The weight of an object depends on the force of gravity. A 10 kilogram object on Earth has a weight of, 10 kilograms times 9.8 would be 98 newtons. However, on the moon, where the gravity is only 1/6 of what it is on Earth, we don't use 9.8, we would use 1/6 of 9.8, whatever that is. So that same 10 kilogram object on the moon would weigh 16.3 newtons. So it's 98 newtons on Earth, 16.3 on the moon. Whatever you weigh on Earth, divide that by 6, that's what you would weigh on the moon. Okay, so what is volume? Volume is the amount of space an object occupies. Different types of matter require different volume measurements. If you're doing regularly shaped objects, it would be length times width times height. And in that case, the units for volume would be either meters cubed or centimeters cubed, right? Because it would be like centimeters times centimeters, which would be centimeters cubed. For irregularly shaped objects, we use the water displacement method, where you have a container with a certain amount of water in it marked off, and then you put the object in, and it raises the water level to a new volume. You take the difference in those two volumes, and that will give you the volume of the irregularly shaped object. For liquids, we use graduated cylinders. For accurate measurements in the kitchen, you might use a measuring cup or a teaspoon. And we want to use liters or milliliters for our volumes. So any description or measurement of an object that you can make without altering the makeup of the object is called a physical property. Of the object. Physical properties include things like is it a solid, liquid, or gas? The color, odor, hardness, freezing and boiling points. Does it conduct electricity? Can it dissolve in water or something else? Right, those are all physical properties. They do not change what it is. They do not alter the chemical makeup of the object. Density is a physical property. We can have two objects that are the same size but have different masses, and there's one that's made of lead, one is made of cotton. Of course, the lead will weigh more, and it's because lead atoms are more tightly packed than the cotton fibers, which is density. Since they have the same volume at different mass, they have different densities. And here's the formula for density, which you should be familiar with by now. So an object has a mass of 300 grams and a volume of 500 cubic centimeters. What's its density? Well, density, mass, volume. You just divide. I'll let you find that out on your own. Use a calculator or something. It's not that difficult. You can cancel out all these zeros, so it's just 3 divided by 5. All right? Hopefully you can do that pretty soon. The density of water is 1 gram per cubic centimeter. Well, the above object, this one here, will it float or sink in the water? And you should explain if it is greater than, if one object is more dense than the other, the more dense one sinks and the less dense one floats. That will be my hint for that problem right there. So figure that one out. Some properties of matter can be measured or observed only when they become a different substance. These are called chemical properties. They include flammability. Flammability and reactivity. I should rewrite those so you can read them better. Flammability is the ability of matter to burn, of course. Wood is flammable, iron is not. When wood burns, it changes into ashes, carbon dioxide, and water vapor, and some other gases. But after burning, it is no longer wood. Reactivity is the ability to combine chemically with other substances. Iron is highly reactive with oxygen. When they combine, they form a reddish powder called rust. But rust is not iron, but an entirely different substance that consists of both iron and oxygen and has different properties than either iron or oxygen. So, hopefully you got that filled out, and you can use that then to complete the worksheet that you will be given when you have finished watching this video. So, good luck.